Swayam Prabha. Digital India. Educated India.
Welcome back, my dear students. This is the 32nd class which is happening for the project management 1. And if you remember, before starting the 31st class, I did make a sincere request to all of you that the problem, even though I had tried to explain it in very simple terms with a very simple example, but it becomes very complicated if the project has lot of activities, lot of interrelationship between activities, and the cost structure is not linear, they are either quadratic or some polynomial sort of thing. And the interrelationship I have taken in a very simple terms, and I have basically considered 1 or 3 different instances how you can reduce the duration of any activity and what is the overall consequence on the critical path, whether the critical path remains as it is or more activities or set of activities now become critical. And I also considered the overall cost structure for the project as you reduce the number of days for the activities which are there on the critical path. So, just and as I mentioned that we did start the discussion of this problem at the fag end of the 30th class. We discussed that in the 31st class, and this is the 32nd class, by which I am sure we will try to wrap up the discussion of the problem. So, now the overall job sequence of the crashing I am now trying to do on 3 accounts, which are as marked in the red color, which is C, D and E, being done simultaneously by 1 days for them. So, 1 days basically means that if I am trying to reduce the number of days, 1 means all of them are decreasing by 1 day. So, but the overall consequence is the decrease which is happening from 16 to 15, point 1. Point number 2 is that you should remember that when you are trying to do that C, D and E at one go, you should also understand whether there are other activities in the overall sequence of the jobs such that they continue to be in the critical activity or the set of activities, and they do not violate the general precedence concepts and all the other assumptions based on which you are doing your project management. So, this point, even though I did not mention when we were discussing the problem in the 31st class, but that is the actual underlying assumption. Now, the cost structure, if you now concentrate, would increase on 3 accounts. Number 1, 1 day reduction in C. Number 2, 1 day reduction in D, and number 3 is 1 day reduction in E. So, let us concentrate on the reduction. So, it will be 1 rupee, 1 euro, $1 for C, similarly 5 units for D and 2 units for E. So, whatever the cost was, let me go back to the last slide. It was 87 here, last to last slide, 87 here. So, now it will be 87 plus 1 plus 5 plus 2, which will be 95. So, now if you concentrate, the costs have increased from 55 to 95 units, and the reduction of the days for the whole project is basically starting from 22 to 15. So, if you consider all these inputs, you will try to basically balance this cost increase, whether it can be offset by the overall profit you are going to make or the revenues you are going to make on different accounts. And if that is true, obviously you will try to analyze your total project in a very simplistic sense in the set of diagrams or set of consequence of discussions which we just discussed. So, now the set of jobs which are bold red in color, which is C, D and E are shown. So, those are the reduction which is happening and the total job reduction, number of days as of now, and also the consequence of what is the total cost has just been mentioned in the last slide. Now, you may be thinking that why did I take C, D and E at one go? I could have done by only considering C, but the point is that all of them are now critical. So, before you took part of C, D, E, if you remember, the number of days of reduction has happened in such a way that it was 16 for all of them. So, where, let me go back again to the slide. So, here 6 plus 5, which is 11, 11 plus 5 is 16, 6 plus 8 is 14, 14 plus 2 is 16, 8 plus 6 is 14, 14 plus 2 is 16. So, all of the paths which was A, C, F, then A, D, D, G, and finally, the last one B, E, G, all of them are critical, number of days is 16. So, that is why you have to look as those sets of jobs or those set of jobs collectively such that the reduction in the critical path happens for all the jobs which are now critical, because these set of activities, as I am marking, all of them are critical. So, obviously, you have to look at them on a macro level such that the reduction is happening on the same quantum for all of them, reduction in the number of days. So, obviously, the cost consequence, if you remember, would be coming both for C, which is here, then also for D and also for E. So, based on that you proceed till the stage where you reach that any reduction apart from that is not possible, and then you have to basically stop and give that whole set of sequence for discussion such that some collective and holistic discussion can take place such that you are able to take practical decisions based on the fact that if the number of reduction of the job the activities has decreased from 22 to 15 and the cost has increased from 55 to 95, whether it is feasible and whether you should go ahead with that. So, now before discussing further problems, I will just go into some more theory and conceptual ideas. So, with that statement I will start the discussion. So, suppose we had a project with only 8 activities. The table also shows our calculated normal activity duration. So, and the cost and the crash duration and their respective costs. So, this is exactly the problem which you have done. I am trying to basically explain with a different problem, not complicated, but a different type of problem with its all its nitty-gritties and the niceties. So, wish to determine which activities are the optimal candidates for the crashing. Assume that the project costs listed include both fixed and variable costs for each of the activities. Now, here you notice this for the first time I am trying to bring the concept of variable cost and the fixed cost. For the last problem which we started during the discussion in the 30th, 31st and this 32nd initial part, the problem had only linear costs. So, I did not differentiate between whether they were fixed, whether they were variable and all these things. So, if the variable part comes, so obviously it will be non-linear, as I did mention. So, here in this table you have again in the similar way the activities are mentioned in the first column on the left. The durations and the normal durations and the normal costs are given. So, for A it is 5 days, B it is 7 days, C is 3 days and so on and so forth. The costs are given. So, the costs are for A it is $1000, rupees, yens, whatever it is. So, it is here dollars, US dollars, it can be Canadian dollars, it can be Australian dollars, New Zealand dollars. For B it is 7000. For C it is 2500, for D it is 1500, for E it is 3750, for F it is 1600, for G is 2400 and for H it is 9000. So, the costs are considering the fact that you have the practical implication of the problem in front of you. Now, you want to crash it. So, all of them would be crashed accordingly. So, if you crash it, you will try to find out that A can be crashed from 5 to 3, not beyond that. So, obviously, there is a limitation for the maximum crash. So, the number of crash number of days for A is 2. Similarly, for B it is 1 day and the cost is given Initially it was 7,000, now it is 1,000. Similarly, for C it is 1 days, cost has increased from 2,500 to 4,000. D is 0 number of days, obviously there is no increase in the cost. E is basically the similarly as it is given and all the costs are given. So, the fully crashed activities in the sense they are given as it is. So, this is very similar sort of problem exactly conceptually and in the same light. So, you have activity A, activity B, activity C, D, E, F, G, H. So, only difference you may find out intrinsically it is not much of a difference. In the initial problem it was activity on arc, now it is activity on node. So, that would not make much of a difference. Only thing subtly you can point out is that in the initial problem I had mentioned only fixed costs and the concept of variable cost was not there, but here I am in this problem I am mentioning the concept of variable cost also. So, the project duration cost by the number of days. So, consider it is given as duration as 27 days, total cost is now 27 where it is coming. If you calculate the forward pass method concept, utilize the backward pass method concept, use the concept of total slack, use the concept of free slack. I am not going to do that immediately, but I will strongly urge request the students to solve the problem before or pause the slide number and do this calculations in an Excel sheet and then resume the discussion which we are having here in this project management course. So, for the durations 27 reduction to 26 to 25 to 24 to 23, 22, 21, 20 and 19, the corresponding total cost is given as 22,450 for the 27 number of days and the maximum cost for 19 number of days is given as 34,200. Now, in this discussion the fully crashed project network is shown as just discussed. The critical path is unchanged though fully crashing all the activities at one go. So, in the first initial problem which we discussed, we had basically taken one activity at a time and then seen that at the fag end all the activities which were there were taken in such a way that all the paths were critical and they had to be basically tackled on a collective sense. So, when you are trying to tackle 3 of them in the last instance, they were done in such a way that all 3 of them separately or collectively affected the critical path such that it was decreased from 22 to 15. So, that one reduction was from 16 to 15 happened in such a way that all the 3 separate jobs have to be taken up in a collective sense. The association of the cost to project duration is graphed as we will just discuss. As each project activity had been crashed in order, the overall project budget increases as mentioned in the table in the last slide. Past crashing activities A, E, H, there is little incentive to crash any of the other project tasks. Now, if you remember I did mention that qualitatively that your choice of which set of activities apart from the practical notion or apart from your experience whatever it is, you will take those set of activities one at a time such that it makes logical sense to reduce the number of days which is there for crashing a particular job such that the overall increase in the cost or the total cost happens in the least possible manner. So, if you remember the activity G that had got a marginal cost of 8. So, rather than basically concentrating at the first instant only G, you would rather concentrate on other jobs such that reduction in one number of days for any one of the activity of the job would be possible in the sense that the total cost would not be per day more than 8, it has to be less than 8. So, if it is 7, 6, 5, 4 whatever it is, obviously you will be tempted and logically so to take those set of jobs such that the reduction in the per day in the number of days which happens is 1, but the increase in the cost only happens to that tune which is less than 8. So, obviously you will take the marginal rate for which is the least. The overall length of the job cannot shrink beyond 90 days, because as mentioned here the number of days are accordingly mapped. The additional crashing merely adds cost to the budget. So, if you want to crash the job further than the number of days which you mentioned here in the bullet point, which is 19 days, you will basically incur more cost without any added advantage. Optimal crash strategy for this project is to crash all only activities A, E and H for a total cost of 11,750, and a revised project basically now becomes 34,200, which means that if I go back to the last slide, initial cost was basically 22,450. The actual cost now after the reduction on the number of days to 19 as shown in the last row, the cost becomes is 34,200. So, what we have is that the total cost is 11,050 and it has become 3,200. So, the total number of days reduced and as of now is 19. So, what you will basically find out that it has basically decreased from 27. I am repeating it, but please bear with me. It has decreased from 27 to 19. The cost have been increased from 22,400 to 34,200. Decision to crash a project should be carefully considered for its benefit and drawbacks. So, as I mentioned that wherever you want to crash a job, you should be careful in trying to analyze which set of jobs or which set of activities should be crashed in such a way that it gives you the maximum benefit. There is always a significant cost associated with activity acceleration. So, those activity acceleration which you are doing, acceleration means you are trying to reduce the number of days. As you do that, it will have a negative impact on the total cost, but obviously you need to balance that with your total revenues. If reasons for crashing of jobs or set of activities are sufficiently compelling, the overall project duration can often be shortened significantly such that you face some cost benefit analysis, which in the long run is positive for your overall decision making process. So, if I consider the cost versus day saved in a fully crashed project. So, now consider this, which would be giving you some idea that even for any activity we consider linear function, but if we consider the total effect on the total job or the total project which you are consuming, it is not linear, it is non-linear. So, technically what I would do if I want to find out the rate of change of the cost structure as it increases for 1 day reduction, I will basically join per day. So, this would be the per day say decrease which is happening along the x axis. So, I will join these points. So, the joint points would be joined in such a way that this graph which I have would be best replicated by the bold point set of points which is there. So, if I want to find out the rate of change of decrease in the number of days with respect to the cost, increase in the cost, I will basically find out the dy dx of that portion on the curve which is front of me. So, what you have in front of you, the graph is basically where you are trying to draw the duration of which is days or weeks, whatever it is, along the x axis and the total cost along the y axis. You have to be careful that how you basically bring all the effect of all the activities collectively to find out the total cost increase of the project, which is at hand. So, for the project controlling techniques, you will basically consider the volume, total resource consumption which is there, and obviously consider that how resource scheduling, resource leveling should be done considering the early start, early finish, late start, late finish concepts are being utilized. You will consider from the point of view of the time and the schedule and consider the critical path and how it is affecting all the activities which are there on the critical path, so that you are able to take a collective decision where you are trying to reduce the number of days with respect to the cost. So, cost will also increase, but on the other hand days will also decrease. So, you have to make a balance. So, the number of units completed or the bill of the quantities to be finished. So, as you do that, you will also try to understand that if the average time which you are trying to decrease is happening with respect to the due date which is there, you will try to find out what proportion or portion of the total set of activities is finished or what is the proportion of the project is finished. So, if you think that some of the critical activities are to be finished if you reduce the number of days for the overall project by trying to crash some activities by 2 or 3 days. So, obviously, it makes sense for you to go for that type of reduction even if the cost increase, because in the long run you will basically benefit by crashing those set of activities of jobs. You will also try to analyze the earned person hours. So, which means that you are paying some money. So, this amount of outflow of money which is happening, whether it is happening trying to basically take the services of vendor, or whether you are trying to take the services of a skilled labor, whether you are trying to take the services of a expert engineer, or whether you are trying to take the service of the best such designer, whatever it is, they should be utilized in such a way that the crashing of the activities, crashing means I am trying to reduce. So, the reduction what I am saying is that only for one day, it can happen for a 1.5 day also, it can happen say for example, for a 3/4 of a day. So, whatever it is happening, you should basically try to analyze the problem from 2 point of view. What are the individual cost reduction or cost increase? Reduction means that you are able to utilize a special machine for a less number of days such that you reduce the cost, but on the other hand you are trying to utilize the services of extra manpower, extra design engineers, extra utilization of extra CNC machine you are trying to basically rent from a vendor in such a way that they are balanced. Balanced, that means in the long run they should be positive effect for your end. So, the earned monetary value should also be calculated, and you try to find out that what is the overall return on equity or return on investment which is happening, so that it gives you benefit, positive benefit. Monitoring the status of the project using X curves. So, if you remember the curves which we considered for the early start, late start, early finish, late finished, for the total cost, that is the cumulative cost functions. So, if you I am sure you remember, we drew the early start, the late start, early finish, late finish, the overall cumulative cost. So, this was the total cost cumulatively, these were the time durations. So, it was T. So, based on that fact, then you leveled, if you remember, the resource leveling was there, whether increase in the overall utilization of the resources was not more than capital R and also not less than small r. So, those balancing needs to be done. So, utilizing those S curves, it becomes a simple tracking problem. You track at each stage and take a decision accordingly. At conclusion of each given time period, we simply total the cumulative project budget expenses to date and compare them with the anticipated spending pattern which you think would have happened. Any significant deviation between the actual and the planned budget spend reveals a potential problem area, such that you have to basically take corrective actions accordingly. So, this S curve which is there in front of you is exactly the same. So, here you have the elapsed time duration along the x axis, the cumulative cost is given on the y axis, and the overall project in general cost. So, consider the early start and the late start, you had basically fitted the best fit line between both of them, so that you are able to utilize the resources on an optimum average value. So, if there is any increase or decrease of the cost, so those which I am trying to now do using the highlighter one, either it can be below or it can be above. So, if it is below and above, which means that if the total costs are fixed and if you are already starting spending much more in the initial weeks, which means some corrective actions has to be taken. So, which means that you are trying to overshoot your cost, or your expenses for some initial activities have been misjudged in such a way that you need to basically be cautious and recalculate your total cost, or to do such management of the activities in such a way that your total cost is reduced. So, here in the bold one and the dotted one, the cumulative budget cost and the actual cost are given, such that you are able to make a comparison between the budgeted and the actual cost which is happening. The problem with the S curve is that the interpretation of the visual information is not easy to obtain. It may be easy for on a macro level, but on the it may be easy on a micro level, but on a macro level it may not be possible, because micro level what you are trying to do, you have lot of informations for each and activities is possible, but when you are trying to combine them, the interdependence of the structure, the looping effect which you have, or the overall sequence of the activities or the sequence of the jobs or the sequence of the resources are in such a way that it may become difficult for you to analyze the overall budget with respect to the actual cost which is happening. For example, does a US dollar of 10,000 shortfall in the example represent a delay in the project, or simply a more efficient process that artificially deflates the overall project has an effect on the expenditure with respect to the date. So, you have to basically answer those type of question and then take a decision collectively. Likewise, a positive variance is not always a sign of a project progress. In fact, a team may have a serious problem with over expenditure that could be interpreted as strong progress on the work, when in reality it signals nothing more than the inefficient use of the project capital resources, which means that if you are trying to utilize your resources in a very big way in the initial, you may be thinking you are able to finish the work much before in time, but in the end when you try to basically analyze your problem with respect to the cost and with respect to the time, you may think that you have been able to save time, but the overall cost may have shot up by a huge amount, such that it will have a negative effect on your total budgeting and total cost and benefit analysis for the project when you are trying to analyze the problem. So, the bottom line is simply evaluating a project status according to its performance on a time versus budget expenditure may easily lead us into making inaccurate assumptions and inaccurate predictions about the project performance. In short, because S curves, which is basically you are trying to analyze the problem from the budgetary cost perspective to the practical cost perspective. So, using S curves only link time to the budget expenditure, we have no way of knowing the true status of the project. So, we must use dollars spent on a daily basis or on a weekly basis or on a unit time, so that you can take collective decisions accordingly. What we need is to means to determine how the project is actually doing, besides how much money is being spent on an equal interval of time. We need a way to assessing the value of the project which has generated to date, and try to basically balance the overall value of the project with respect to whatever our plan was. Earned value management is just such a method of accessing the project status, based on which you can take a decision whether your actual work which is going on is in line with whatever you have planned. Now, all the discussions we have been doing till in the 30th class, in the 31st class, in the 32nd class has been based on the fact that few of the assumptions, even though I am repeating it time and again, but please bear with me, is number one, you are always considering the concept of end to start concept for the sequencing of the jobs. Number two, the concept of looping was not there. Never in all this set of lectures starting from the first till this 32nd class, we have never considered looping as a practical way of trying to handle the problems. Even though practically to handle the problems in the shop floor, in the project management perspective really does make sense, but trying to bring them in the picture when you are trying to handle them from the theoretical perspective may become difficult. Point number two is that we did consider the concept of distribution to be beta, and then we did consider the A value, the B value, the M value, but in all the cases it may not be true that how you tackle the problem. Number three is that the cost perspective which we have are not linear, they are non-linear in nature, hence trying to find out the marginal rates may be difficult. Number three is that when you are trying to basically find out the total cost, there would be interrelationship between the activities. So, if you consider the activities which are there when you are trying to basically sum up the variances, we did consider that the activities are independent, which is not true. And also considering the central limit theorem, that means you are trying to use the normal distribution, was a nice way of trying to tackle the problem from a very simplistic probabilistic point of view or a distribution point of view, but in generally that may not be true. So, with this I will just end the 32nd lecture with a note that the two different type of problems of discussion we had for the crashing of the jobs were simplistic, we agree, but I am sure they would give a very good viewpoint that how the concept of crashing of a job, trying to analyze the problem from trying to trying to see how the cost increases, whether it is feasible or not, whether the critical paths are which were initially, whether they now encompass all the activities, they should be considered step by step, such that we get a much better picture how the problem can be solved. Plus we should also try to analyze the problem from the monetary perspective, that what is the overall excess cost we are trying to utilize over and above the budget, such that we are able to make some actual practical and realistic decision with respect to the resources, with respect to the time, and with respect to the costs which are basically we are incurring. And obviously that has to be balanced from the resource cost perspective. So with this I will end the 32nd lecture, and from the next day, from the 33rd till the last lecture, we will try to basically cover some other new topics related to JERT, QJERT and other such important concepts which are very heavily used in project management. Have a nice day and thank you very much.